Hi, today I would like to show you the stories in SCIA Engineer. How to input them, how to allocate the members to stories, change the visibility of your structure, what can you use from the stories in the earthquake analysis, and on the end, what you can display on special story results. My name is Ivan Beleš and I am support engineer for SCIA Engineer and Idea Statica. I have prepared two structures. The first one is very simple. You see it on the screen. There are no stories defined. So first we will define them. You find it in the input panel. You can go also, if you want to filter it, you can go to structure and then you see the stories, or you can use the command stories. How do you want? In the stories you have names. These names will be generated, so you can define only the first text and the number, and it will be continuously increased. Then you have the bottom level of the first story. So if you want to start with the structure below the 0, so you have to input some minus value because you cannot move it then later in the structure. So then the height of the first story, and if you have the equal heights, you can define the repetition. And then there is description, but this cannot be displayed in the structure, so it's only only here. And you have the inserting point, so you can move it outside of your structure, for example. And of course with OK, it's defined. So you see only a part, because this is a structure which I have used for a webinar this week. So I click on Ctrl Q, and this is visibility off. This is visibility off, the Ctrl Q, and then you see the full structure. I will explain why it was not visible. If you want to change anything, simply click again on stories, and then you are directly in the definition. It will be not created second time because you have only one definition of stories, so you simply edit it. This is not like in the grid, 3D grid, where you can, with this button, with the button for 3D grid, create a new button. So this is the same for editing and creating. If you was in the definition of the stories, then you are in the grid mode. This is the same like in 3D grid. If you want to edit the structure later, you have to turn the grid mode off. So if you see, I cannot click on this wall, for example, or this one, because I am in the grid mode. You see it here on the right top corner. You can deactivate the grid mode, and then you are in the structure. Now you can change the structure or edit whatever you want. First, we have to allocate the members to stories. And there is one difference from the allocation, for example, to layers or so on. You can have one member which is allocated to more stories. One member is not only on one story, because you can have walls, they go through 2 or 3 stories, so you can allocate them to more stories. There are two possibilities. First, we go through the automatic allocation. If you want to automatically allocate members to stories, simply select the stories, and then you have the possibility to automatically allocate the members. If you do it, you have to decide if this member, this is the horizontal member, which is exactly between these two stories. It must be exactly on 1 millimeter. Then you can decide if this member will be allocated to the floor 1 or floor 2. If you say include members on top, then this 2D member will be allocated to floor 1, and you have to usually deactivate the bottom part. but you can do it also on opposite way. This is the common way how it's done. And then you have the allocation type. All inside means that this wall will be allocated to floor 1 only if it is completely between the 0 and plus 3 meters. For example, this wall is outside of these 3 meters, and this will be not allocated to floor 1 and also not to floor 2 because it's not completely inside of one story. So if you want to allocate it on this way, you can go, for example, to part inside, and then each part which is partially in the story will be allocated to the story. So you simply have to select them, click on this, you get no message. This will be done in background. How do you see that you have done something? There are two ways. So first you can, we go to the visibility. View visibility by story. And here you have the possibility to see one floor. I have used this model in the German version, so sorry, it is saved from the German version. This is one story activity. So I say the story to floor 2, and then I see only members, they are allocated to floor 2, and you see each member which is partially in this floor is allocated there. So, and yes, that's the one. This is allocated to floor 1. So if we go back to it, visibility, so you know you can use shortcuts by story, for example, Control G. This is for German Geschosse. So you can activate it, and I can say, for example, only floor 1 or floor 1 and 2, and then you see what is allocated to floor 1. Here is, I go to Control G. Here is one very interesting part which I never used. This is not allocated members. So if you have some members, they are not allocated to some story, then you see them. You see it now during the input of the structure. Usually I get calls from the customers, Mr. Belej, I want to see the story results, but some walls are not displayed because they are not allocated to the story. So you can see it immediately during the definition. You don't need to wait after the calculation. So Control G, I see, or Control Q, I see everything. Control Q is here, this first button or function. This was the automatic allocation and the visibility. If we are talking about the visibility, if you select some stories, I select them, then here is this interesting button, current used activity. If you deactivate it and you go to some activity by selection, this is Control E, for example, I select these two walls and this plate and go to Control E. You see the definition of the stories is not visible because I have turned it off. Control Q, I see the full structure. So if you want to see these stories, every time you have to activate this current used activity. And now, if I select them, go to Control E, then I see the stories, and Control Q, I see the full structure. You can allocate the members manually. If you want to do it, then select only one story. You cannot do it for more stories. And then you have two possibilities. You have this filtered allocation. If you click on it, then you see the parts, they are allocated to floor 1. And you can add something or remove. For example, I will remove everything. Escape to deselect, select this floor, go here, and I will remove all definitions which I have done from the stories. So there are no empty. If I go to the activity or visibility by story, and I say I want to see not allocated members. I should see the full structure, of course. Control Q, again, everything. So, and now I can allocate the members manually. So I can do it by this filter, but I don't know what is I don't know where are these parts. So therefore, so you can use here the named selections. You can make selection and save it under a name, and you can use it here, but we will do it on another way. You can go to set allocation. If you select one story, you can go to set allocation, and now you can select by mouse, for example, this one, and also these plates, right mouse button or escape to deselect. If there is already selection and you want to change it and you don't want to do it by these names, select the floor, go to set allocation. You see all parts, they are allocated, and if you want to remove something from there, shift and click on some parts and you can remove them. And again, edit. So with shift and click, you can change the selection, select or unselect. So this was, for example, also escape, it's done. So if we go with Control G to the stories, story number 1, then I see what I have selected manually. So you have it on this way, fully under your control. If you have some doubts, deselect everything, remove everything and do it again. Or change it, whatever you want. Then there are small settings about colors and visibility. So you can go to this button, view settings for all entities. You go to modeling drawing and you can change what do you want to see from your stories or deactivate them, for example, completely. And if you want to change the colors, you go to colors and lines, and then on the bottom of the list there are colors and text. Font, there are stories here, in my case blue, and for the fonts also on the bottom there are stories. This is the height of your font. The stories are not only used for visibility, they are used in the calculation. So first, this allocation of the members, for example, walls to stories, don't change the calculation. What I have done is only for visibility. If some wall is not allocated to a story, then it doesn't mean that it's not calculated there. Only you don't see the results. If you go to story results for floor 1 and some wall 1 is not in this story 1, you don't see the results, but the results are there. So you have only to change a little bit the allocation. You don't need to recalculate, you immediately then see the results of this wall. So the allocation of the members to the stories don't change the calculation. So this is used for visibility. But there is one point which is used really in the calculation. If you have stories, then you can reduce your structure for the calculation, for the model analysis to multi-mass system. So you can go to the help in SCIA Engineer, you have this nice picture. So if we have stories, then you can activate IRS. IRS is improved reduced system. Then the system will be for the model analysis reduced to very simple system where you have 6 degrees of freedom for each story. And after the calculation, it will be again exploded to our shell model, and so you see the standard results. But the advantage is, if you have a bigger structure, sometimes you need to calculate 200 or 500 eigenvalues. And with this, you calculate 6 times the amount of stories. This is the maximum amount of eigenvalues which you can or must calculate, and you have almost 100% of your total mass in the calculation. The allocation of the masses to the stories is done automatically finite element by finite element. So if some ball is not allocated to the story, it doesn't mean the mass is not there. So the mass is calculated automatically. You need only the heights, correct definition of the heights of the stories. One advantage of this calculation is also that you can activate the accidental eccentricity. No, why I don't see it? Okay, it's there. So there is some accidental eccentricity. We have the eccentricity of the stiffness center to the mass center. This is calculated automatically, and you can add this 5% of the width of your structure as an accidental eccentricity. This can be done only if you activate the improve reduced system. Improve reduced system will be activated in the settings of the solver. For this, I go to my second model. And in this model, I can go to calculation mesh, solver settings, and in advanced solver settings, you have this, where is it? Dynamics, use improve reduce system. So this can be used only if you have stories in your model. And then you can also deactivate some directions. For example, if you have such simple model, this is from university, from seminar, so it's very simple, then you can deactivate the Z direction because my walls are going from the bottom to top without a gap. So they are going through all stories. So I don't need in this case to calculate vertical direction. And I have only 5 degrees of freedom for each story. So 5 times my amount of stories. If you calculate the amount of stories, then all, so this 1, 2, 3, 4, 5, 6, because also this first floor, because if we don't do nothing, we did nothing, then the half of this story would be go to the supports directly. So there is also in 1/4 of the height, one story defined to keep the mass completely. So 5 times or 6 times the amount of stories is your amount of calculated eigenvalues. And now to the results. You can find the results in the results or here, results, stories. There are summary results or detailed results. So first go to the summary results. They are here, summary results also. In the summary results, the first what I look in, what I check in the structure is the mass per story. So if you have it, you can go to mass combination and you can change the result type to story data for all stories and refresh, and then you get the mass for each story. Or what you can get is displacement, for example. Then you have to go to load cases, for example, earthquake in X direction, and I want to see the horizontal deformation in this direction. Or what is interesting, inter-story drift, or the maximum deformation between the stories. So there are some interesting things, especially for the earthquake analysis. I would like to see the full weight of one story from self-weight, for example, or from some another load case. Then you go to the detailed story results, and in the detailed story results you can see the results for each story or for members, so you can decide. So I go to member grouping per story. I want to see the vertical force. If you go to per story, then this definition of the coordinate system is from global coordinate system. So that means Fz is the vertical force. And for example, I want to see from eigenvalue all stories in the middle Or if you want to go to the bottom, you can say in bottom, but maybe it's better. I use usually 1.5, 1.1, so 10 centimeters above the story. Then I have the full weight of my wall in the calculation. So refresh. And then I see the weight of the story, the total vertical force from self-weight. So of course you can go to combinations or another load cases. So this is for the story results, and you can go also per member. Then it's better if we look only on one story, for example, floor 2. So I go to single story, floor 2. I want to see from self-weight the vertical force, but if I am going to per member, then I have to change it to Fx. So you can imagine you have in each wall some integration strip or some rib. Then the x is the vertical axis of this, I would say, beam or column. Then the y-axis is in the plane of your wall, and z-axis is perpendicular to your plane. So if we look at Fx, we see the vertical force for each member, extreme value for each member, refresh. And I want to also to see only one floor. I go to Ctrl G and change it to floor 2. For example, I see only floor 2. Refresh, and then I see the vertical force from self-weight for each wall and column in one picture. So it's very good picture if somebody is checking your structure with these 2D softwares, like for example Freelo, they use these results. So for each member, and you have then one picture with all vertical results, for example. But sometimes you don't need this vertical force. You need, for example, the distributed load, trapezoidal or constant. You can change it here. Instead of result forces, you can go to internal forces. Then for the column, we need vertical force. And from the walls, it's a little bit covered here. And y, this is the vertical force, if you don't change the coordinate system of the walls, of course. So refresh. And then if I look from the top on it of the structure, I don't need the units. It's too much. Then you see the distributed load per meter. This is per meter, but sometimes you get the peak values, and if you don't want to have it, then you can change it. Internal forces. Where is it? On the bottom. Instead of precise, you can go to trapezoidal. Then you get this trapezoidal. But if you want to have constant, then you turn this off and you can activate average value or this total value. But that's the same like the value before. So, and then you get the constant value, for example, as a reaction from your one floor, and you can check it very good with 2D software, or if you send it to some authority, you want to change it, you can do it. So it's very nice results. Okay, I'm on the end. Thank you for your time, and maybe you watch the next video. Bye.